So for this question, we're going to find the area between the curves of y is equal to sine x and y is equal to negative cos x from 0 to pi. And the difference between this question and some of the other ones we did is that there's going to be a point where the top function will become the bottom function, right? So they'll just flip. So we just need to do this in two parts. Just think about it. We just need to do it in this part where we've got our sine x as our top function. And then we're just going to add the area over here where negative cos x is our top function. That's pretty much it. So let's figure out where this actually crosses, because we're not exactly sure right now. We might be able to guess it, but let's make sure. So we'll set these two equal to each other, like the y values are the same. So we'll say sine x is equal to negative cos x. So now to solve for this one, what I'm going to do is I'm going to just divide both sides by cos x. So now we have sine x over cos x is equal to negative 1. So we're getting a little closer here. Okay. So let's actually just rewrite that now as tan x. So we're really saying, where is tan x equal to negative 1? Or what's the value of x that would make that true? Well, if we think about our quadrant, in our unit circle, then where that would be true would be over here in quadrant 2, right? That's where tan is negative. Just thinking of it like your cast rule, right? So that's where tan is negative. And that angle would be at 3 pi over 4. It would also be the case down here, but I see that the angle I'm looking for is before pi, so it's not going to be that one. Okay, so it's going to be at 3 pi over 4. Okay, so that is where, so it's going to be x, it's when x is equal to 3 pi over 4. All right, so that's going to be our transition period, so, or transition point, I should say. So let's take the integral. All right, so I'm going to say area 1, if my pen would work. There we go. So area 1, which will be just this area, is going to be equal to the integral from 0 to 3 pi over 4 of, and then we just got to make sure we get this right. So it's going to be the top function, which in this case is sine x minus, and then the bottom function is negative cos x dx, which is the same thing as the integral from 0 to 3 pi over 4 of sine x plus cos x. All right, so this is negative, so the integral of sine x is negative cos x. Plus, and then the integral of cos x is sine x. And that would be from 0 to 3 pi over 4. So this becomes negative cos of 3 pi over 4 plus sine 3 pi over 4 minus negative cos of 0 plus sine of 0. Okay, so now this is negative, and cos 3 pi over 4 is negative root 2 over 2. And then plus, and then my sine value there is also root 2 over 2, but positive root 2 over 2. Okay, and then minus. So then here we've got, so negative cos of 0 will be 1, and then sine of 0 is 0, right? So this this is minus negative 1, which would really be like plus 1, but I'll save that for the next one. So now we've got root 2 over 2. Actually, maybe I'll do this right now too. So this is positive root 2 over 2 in the end, right? So then putting those together, we now have 2 root 2 over 2's. So those cancel. And then we have plus 1. Okay, so maybe just writing it one more time. We've got the area is equal to root 2 plus 1. All right, and that was area 1. So we're going to need that in a minute. So circle it or put a box around it. And then we're going to do the same for the next part. Okay, so now what we're doing is we're figuring out this area. Okay, and that's going to be starting from 3 pi over 4 and then going to pi. Okay, so that'll be our area 2. And that would come from the integral from 3 pi over 4 to pi of. And then just be careful because it's flipping now, right? Our negative cos x is on the top and our sine x is on the bottom. So it's negative cos x minus sine x dx. All right, so the antiderivative for each of these would be, so this become negative sine x, and then derivative of sine x is negative cos x, so this will now become positive cos x from 3 pi over 4 to pi. Okay, so now putting this in, so we'll start with pi. So negative sine of pi plus cos at pi minus negative sine at 3 pi over 4 plus cos pi over 4. Okay, and then we'll just work through this now. So lastly, so sine at pi, that has a height of 0, right? So that's comes with a 0. Cos at pi is negative 1. So this all becomes just negative 1 minus. And then negative sine at 3 pi over 4. So sine at 3 pi over 4 is just root 2 over 2. So now it's just negative that. So negative root 2 over 2. And then cos, oops, this is at 3 pi over 4. Sorry, you might have noticed that. Okay, so then cos at 3 pi over 4 is negative root 2 over 2. So we just have 2 of those. So negative root 2 over 2. We've got negative 1 minus, and now this will be negative 2 root 2 over 2. So those cancel. And we have a final answer of negative 1, and then this would be plus root 2. So it looks similar to our last answer. So now let's just add those all together. So this was our area 2. So our final area for the whole thing, so area total, would be area 1 plus area 2. So the area total would be, so area 1, if you remember, was root 2 plus 1. Root 2 plus 1. And then plus, and then my area 2 was this one. This was, so negative 1 plus root 2. All right, so we see that our 1's cancel, and we just have root 2 plus root 2. So our total area here would just be 2 root 2.